see, what other fun ones should we do? Good morning, everyone. Let's start with practice. I'm going to just keep putting a few problems out, but go ahead and start working on them. Of course, if I've given the name, give me a formula. If I've given you the formula, give me a name. Ooh, how about... Let's see how many of your classmates will remember that we're doing Thursday this week. We'll find out later, I guess. Alrighty, so go ahead and take a minute and do these. Once you have something there, put it in the chat. So Sherry has said ZNCl. I don't agree. We have to remember zinc always takes a +2 charge. And chlorine will always take a -1. And so actually we're going to have a 2 with a chlorine there. So yes, don't forget zinc always is +2, so is cadmium. That's one of the ones on our handy list here somewhere. Let's see. Handy list. This one? Yeah. Don't forget zinc here. Only ever takes +2 as a charge. So just remember our fixed charge. We have 3, 2, 1. Just going diagonally down. One way to remember it. And so, yeah. Okay. What else do we have? Who's got the next one for me? Mm-hmm. Don't be afraid. Go ahead. Put something out there. Let's have a look. Okay. Well, one thing that's good, we have seen that you have identified this as silver. So what's getting us stuck here? No. Sherry has it. So, Lamonda, we have to remember silver also is one of the ones that only has one charge, and that charge happens to be +1. And so that 3 that you see there is actually part of the carbonate ion. It's not a subscript for purposes of balancing. That's just part of carbonate. So when you do the crisscross, we find that we're only going to need 1 carbonate for 2 silvers. And so that's where that 3 is coming from. So yeah, this definitely takes time to learn your polyatomic ions, and that will help you go through this. So very good, Sherry. Very nice again. Nitrogen, trifluoride. Notice again, if we were to identify the type of compound for all of these, zinc chloride is ionic. We have a metal there, zinc. We have silver carbonate that's got a metal also. And now we have a covalent compound, only nonmetals. And we should also be able to get this one as ionic, and this one should be covalent. So don't forget magnesium is always 2+. And so you're going to want to find out what the heck this ion is. Again, it'll make things a lot easier once you get to learning the ions. And so we're going to see, do we have anything that is C2O42 minus? And indeed we do. And that will be oxalate for us there. So again, it will behoove you to have this for easy access or memorized. Of course, this one is just magnesium, right? Magnesium is always +2. So what else do we need to put for this compound? We just have to remember it's going to be the trihydrate. Perfect. Yes. And last one, hopefully the easiest one of them all so far. Covalent compound, of course, because we have dyes and tetras and all that fun stuff in there. For that one, it's just going to be, and just in case any of you have thought about stuff like this, we never reduce covalent compound subscripts. Yep, looks good. Yeah, so just remember, don't ever reduce this to like SBr2 because that would be a different compound. So for us, we do have to reduce it if it's ionic, but not if it's covalent. Okay, let's deal with pesky hydrogen. So hydrogen exists as two potential ions. We're going to see that when we mix hydrogen with metals, we will form the H- ion. And if we put hydrogen with non-metals, or negative polyatomic ions, it will be a positive ion. These, of course, are called hydrides. And for example, we would name it like any other ionic compound. So even though hydrogen is technically a non-metal, we will name compounds as if hydrogen was a metal. For example, we would name this guy hydrogen chloride. Or this we would name hydrogen sulfide. So as if it were just like sodium. It's just an H plus ion. It would be very similar. We would just replace hydrogen with sodium. Now we have NaCl instead of HCl. Sodium chloride, hydrogen chloride. Fun fact, this compound is actually best called hydrogen oxide. You may have, heard of the, hoax from whatever, where people were saying dihydrogen monoxide is going to get you, or whatever. We pretty much never use non-metal naming rules for hydrogen-containing compounds. Particularly because hydrogen only has one electron, it's just going to give that away. And so there's really no need to put the di and mono there, because there's only going to be one compound that hydrogen can make with the oxide ion. Okay, exciting. Yes, just like a metal. However, something special happens when H plus containing compounds are dissolved in water. For example, hydrogen chloride is typically a gas at room temperature. If we were to dissolve it in water, it will actually behave quite differently. So this AQ that I've written here stands for aqueous, and that means dissolved in water. Of course, you might see things written solid, liquid, or gas. Those letters just mean what you think they mean, but this AQ1 means it's dissolved in water. And we see when these H plus compounds are aqueous, they act as acids. We're going to learn about acids quite a bit later in the semester, but we are going to learn how to name acids right now. And so we're going to see that because all acids have H plus, the name of the acid is based on the anion. And so, if we go ahead and do a couple of examples, if these guys are aqueous, we're going to name them as acids. And for right now, I'm just going to give you examples with their names, and we're going to figure out what the pattern is for naming these. This one is called hydrochloric acid. This one is called hydrosulfuric acid. This one is called hydrobromic acid. Here's another one. This one is hydrofluoric acid. And so, if we look at the anion of all these, the anions here, and if we remember the names of these anions, this one was chloride, sulfide, bromide, fluoride. We see that all of these anions end with "ide." And we notice we also have some things that are similar about these acid names, right? We all see they all start with hydro, and they all end with ic acid. And so, we're going to see that if the anion ends with "ide," we name the acid hydro something ic acid, where what goes in here, this will go, the name of the anion without the "ide" ending. So notice we had fluoride. We are going to drop the "ide," so we have fluor left. And now we're just going to kind of plug that into this template. So you can hydrofluoric acid, hydrochloric acid. So let's take a look at another example. This one is made of these two, right? The name of this guy is iodide. And so what we're going to do is we are going to kind of get rid of that "ide" ending. So we have this iode part. And that's going to go into hydro. Oops. we're going to go ahead and put that into our kind of template. So this one becomes hydroiodic acid. Alrighty? Some of the polyatomic ions, not very many of them, also end with "ide." This one is the polyatomic ion cyanide. Again, we're going to kind of have that same idea. We're going to get rid of the "ide." And we are going to call this hydrocyanic acid. Oh, I forgot to write AQ. Don't forget, for all acids, their formulas must have that little AQ bit. Otherwise, we would call this hydrogen cyanide. So, and that's going to be the, almond-smelling gas that kills you. That's hydrogen cyanide. So, if it's aqueous, it's hydrocyanic acid. All right, so far so good. I hope. Alrighty. I have a couple more acid types for us to talk about. And I'll go ahead and tell you the names of these guys. By the way, sulfur is kind of special. Sulfuric acid kind of violates the pattern a little bit, but we'll see what that looks like in a minute. And if we look at the anion of all these, you can look at the anion names. This one, carbonate, sulfate, nitrate, oxalate. And so again, we're going to see we have a pattern here. That if the anion ends with 8, we're going to make it just ic acid. So no hydro, just ic acid. We drop the 8 and make it ic acid. So technically, so you see how we've taken carbonate, we've gotten rid of 8, and added ic acid. So now it's carbonic acid. With nitrate, we dropped the 8, added ic acid, and now it's nitric acid. So notice that we would expect the second one to be called sulfic acid, but for whatever reason, we still call it sulfuric acid. So that one and phosphorus, phosphoric acid, are kind of special, but the rest of them will all follow the same pattern. So let's take a look at a few more examples. about we do, what would be a good example? I know. Yeah, that'll work. Okay, so let's take a look at the anion name. The anion, or let's look at what the anion is. ClO4 minus. So again, this is why it'll be very useful for you to have learned these polyatomic ions, because otherwise you're going to have to keep going back and forth to the chart. I know I'm a broken record, what can I say? Okay, this one is perchlorate. So just like before, we drop 8. And keep the rest of it. This one is chromate. Again, drop the 8. Keep the rest of it. Chromic acid. How is this so far? Are we okay with this one? All acid naming comes down to just identifying your anion and knowing its name, and from that you can generate the acid name. So one thing that we've probably noticed is that acids always have enough H plus to balance the anion. So just so we know, let's try kind of going the other way around here. Let's try doing going from the name to the formula. Alrighty, so both of these have that ic acid, which means they came from things with 8. Remember, this one came from something that ended with 8. So, you have to say, okay, iodate, acetate. We go to our chart of polyatomic ions. We see iodate is IO3 minus. We see acetate is this guy. And so both of these will only need one hydrogen, right, to balance themselves out, because they're both -1 ions. And so we're going to see that once we put it together, we just need enough hydrogens to balance it out, and we just have to stick the aqueous part at the end. Same thing here. Notice we will keep that one separate. So we're always going to start our acids with H. So we will not do something like this. for this particular acid. So we're always going to kind of keep our H's that are the H plus part separate. Just like with ammonium nitrate, we kept the nitrogen separate. It's the same idea here. How's this looking? We just have one more, and that's it. Then we're done with naming, and we can just practice, 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 practice. So now we have our last one. We're going to have a couple of examples here. Okay. Name of these guys. Are these. So notice these are also ones that have a pattern based on the anion. But first let's go ahead and look. These all have us acid on them. And that's going to be the part that we're going to use if our anion ends with ite. And so this one is nitrite, hypochlorite, sulfite. So again, same thing. We're going to have this ite ending. And just like before, we're going to see if it ends with ite. We're going to drop that and make it something us acid. So let's see. What other ites do we have? We've got this one came from bromite. So we drop the ite and make it bromous acid. What other phosphite, I guess. I don't want to do phosphite. Let's see. What other ite ending ones did we have on our list? Let's see, what can we do? An example of ite. Have we already done them all? Yes, I mean, yeah, iodite would be the same idea. Well, whatever. Okay, we can do that. Same thing, drop the ite. And we get iodous acid. I guess we can do the phosphorus one. This is phosphite. We have something special here. Remember, sulfur and phosphorus kind of do weird things. This one is going to be phosphorus acid. So just like with, I'm going to do it again, but with sulfite, we also had a kind of special one. Phosphorus and sulfur are just special. They, instead of just taking phosphorus acid or sulfus acid, they keep one more syllable. Again, I'm not quite sure why it's the way it is, but just notice we keep this extra bit on it. And it'll be the same, so phosphoric acid instead of phosphic acid, hydrophosphorus acid. You'll always keep them with phosphorus and sulfur. Okay, here's one way to remember it. Sulfur and phosphorus, S and P, are special. They have special bits. Here's a happy face. Okay. So just in a nutshell here, our too long didn't read version, we have I guess I'll do it in the order that we did this. Boom. There are our acid rules. So we look at what the anion is. Just so you know, I have one more thing for you to know. Is that these guys always have polyatomic ions. And I don't know if you've noticed, but almost all of the polyatomic ions are oxygen-based, right? You have this whole chart of polyatomic ions, and almost all of them have oxygen. Look at this whole bottom 12, all oxygen, everything in here, oxygen. Everything here except cyanide, oxygen. Oxygen's everywhere. So as a result, we sometimes refer to these as oxy acids. Notice also the one that does not have an oxygen, the only one for us on our list, is cyanide, and note that does not have an ate or ite ending. So every time you see an ate or an ite, that's telling you you have a polyatomic ion, and that polyatomic ion will have oxygen in it. So sometimes you'll see these called oxy acids. Okay, any questions on that so far before we put it to the test? Wait, what? No, I don't want this. There we go. No? Okay. Practice time then. So I think a good way to practice, or a good habit to do, at least while we're kind of learning here. Wait a second. This is bizarre. Why is that happening? Oh, I see we've disconnected. Okay, that would be a good reason. We can fix that. I was wondering why it hadn't loaded. Okay, is this where we need to be? Yes, it is. Okay, so sorry. Yes, Lamonda, it's because they don't have oxygen. And it's also to distinguish between them. So putting the hydra there is kind of how we distinguish oxyacids from non-oxyacids. What did we... Tablet has exploded. Oh no. Okay. Well, hopefully... okay, what I'll do is I'll restart the tablet. Work on those 4 in the meantime. I'll go ahead and type them in the chat here while I restart the tablet. That's the first one. Second one. And the last one. Okay, so restarting tablet usually fixes all my problems. But we'll see. Okay, so go ahead and do those. And look, for now, what I'll do is I will put up our polyatomic chart. So now we can see it easily. So while you're working on these, you can have that for easy access. And just so you know also, all of these acid rules are down here at the bottom. So again, easy access for us. Okay, tablet has restarted. Let's see if it's going to behave. The other option is it's the laptop that's being naughty, but we'll see. I like that first one, Lamonda. Looks good. Oh, I know. That's why. So chloric acid is definitely the first one. Very nice. Oh, really? All the way to the end. There we go. So Lamonda has identified that the anion was chlorate. And so we have changed the name to chloric acid. We dropped the 8 and we made it chloric acid. We've also got this as iodide. And so this will be hydroiodic acid. Alrighty, we got 2 more. Looks good. I've been using blue. This is phosphate. Just remember, phosphate is a special one. Remember SP, special, sulfur and phosphorus. Great job. Yep, perfect, perfect. 4 out of 4. Very nice. So that was the chlorite ion. And so this will be chlorous acid. Very nice. Any questions on those 4? All right. Let's make you all go crazy now. Now, I'm going to give you all sorts of different compounds. Apparently, I'm in a chlorine-based mood today, but here we go. Okay, do these. Have fun. Though, though. Just in the interest of time, I am going to write the names here, just to give you more examples. So I would have liked to give you the time to work on these, but I want to also do a couple where I've given you the name and asked you to generate the formula. So if you want, you can go ahead and pause the stream if you want to work on these and just resume it, and then you'll see the answers. So you can do that live. You could do it right now if you want. Or you can just, accept that I've given the answers. No. Ooh, exciting. All right, so there's all those. I'm going to do a couple examples of name two Formula Ones. So again, same idea, just pause it if you want, and then resume later if you want to do them, and then see the answers. Okay. Let's use something besides chlorine. This time we'll use bromine. What else can we do with bromine? Let's do that. Okay, same idea. Hooray! Okay, so tons of problems for you to, or examples for you to see right there. Hopefully there are no questions on those guys. But as always, just drop them in Discord if you have any. But you should now be fully equipped to answer all those homework problems. So again, I've put a ton of them up there for you. There's a few of them that you might have to look up. Just like there is ones that say Stanek and stuff, where it's kind of these old names that I don't need you to know, but maybe it's a good idea anyway for you to practice those. But by and large, most of them you should be able to do pretty easily. So again, this is just practice. Tons of practice. So my suggestions: identify what type of compound it is. Is it an acid Is it a covalent compound, or is it an ionic compound? So acids, remember, they'll have H plus and some sort of anion, and they're aqueous. We're going to see covalent compounds do not have any metals or positive ions, and ionic compounds do not have, or they have charged species that are going to be a metal, non-metal, or polyatomic ions involved there. Let's see. That chart I gave you has all the naming rules for all the different types of compounds. And so it's important that we spell things correctly, because as we can see here, changing one letter from, "ide" to "ite" can make a big difference in what the compound's going to be. So with that, we're done with this good stuff. So again, just practice, 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 practice. Lots of work for you. Lots of grading for me. Not fun, but whatever. And so, okay, so with that, I will, I guess we'll end 2 minutes early today. That's all right. And yeah, so go ahead, put questions in Discord. Otherwise, have a nice weekend. Don't forget your homework is due on Sunday. And I will see you on Monday. Okay, take care.